In the second part of this video on abstract classes and interfaces, we will provide the syntax for defining and implementing interfaces and provide an example of both. We will compare interfaces with abstract classes and then discuss two of the most frequently implemented predefined interfaces. We begin with the definition of an interface. An interface is best defined by explaining what it is allowed to contain. First, it can have abstract methods. These methods are implicitly abstract and public, so it is customary to omit both modifiers. We can have data that is implicitly public, static, and final, which means they are constants. As before, omitting all three modifiers is customary. Beginning in Java 8, interfaces were allowed to contain class and default methods. Unlike abstract methods, both do contain bodies. We mention this fact for completeness, but do not plan to provide examples of interfaces that contain either of these new features. Let's consider the syntax for defining an interface. Like a class name, an interface name is a type. The syntax for defining interfaces is very similar to classes, except that in place of the reserved word class, we use interface. The other difference is what can go inside of an interface. It cannot contain either instance variables or instance methods. Next, we consider an example of an interface definition, addable. Interface names often end with the suffix able to suggest that they define an ability. The ability that this interface defines is the ability to add one object to another, a capability similar to what the plus equal operator does. Notice that because method signatures in an interface are always public and abstract, we have omitted them both. Now let's consider how an interface is implemented. Notice that Java elected to use a different reserved word, implements, rather than extends, to express the relationship between an interface and the class that implements it. Let's see how that new reserved word is used. Like the extends clause, it is an optional clause that follows the class name. But unlike the extends clause, it is possible for there to be more than one interface name listed. When there is more than one, they are separated by commas. Unless the class itself is an abstract class, it must implement every abstract method in the interface. There is one important difference between extending classes and implementing interfaces that the syntax above conveys. A class can implement multiple interfaces, but can extend only one other class. Here is the UML diagram that shows the interface addable that we discussed earlier, together with a class addable length that we will examine next. Notice first that like abstract class names, interface names are italicized. Although a hollow arrowhead is still used to express this relationship, a dashed line is used to indicate that the relationship is implements rather than extends. Next, let's examine the addable length class. Notice first that it implements the addable interface. Like the length class that we used in the previous video series on inheritance, this class contains a constant defining the number of inches in a foot, instance variables containing the number of feet and inches, and a constructor to initialize both. To satisfy implementing the addable interface, it provides the add_to method that behaves in a fashion similar to the plus equal operator. It allows one length to be added to another. Notice that normalization is required after the addition to ensure that the inches remain less than 12. It accomplishes that normalization by calling the private method normalize. So let's scroll down to look at that private method. The normalize method first calls another private method toInches to convert the length to all inches. It then uses integer division to determine the number of whole feet, and then the remainder operator to determine the number of inches left over after extracting all the whole feet. The SumAddables class gives us a complete program that we can run. In the main method, we have an array of type length that contains 3 length objects. That array is passed to the method computeSum, which returns the sum of all the lengths in the array. Notice that the computeSum method contains no references to the type addable length. That method could be used to compute the sum of any type that implemented the addable interface. The ability to write such methods that depend only on the capabilities provided by the interface is one of the key benefits of defining interfaces. Let's run this program to see what output will be displayed. We see now that the sum is 3 feet and 6 inches. As a review, let's summarize the similarities and differences between abstract classes and interfaces. First, the ways in which they are similar. Both can contain abstract methods, which must be overridden in the case of an abstract class or implemented in the case of an interface, eventually along every branch of the inheritance hierarchy. It is not possible to instantiate objects of either abstract classes or interfaces. Beginning with Java 8, both can contain class methods. Next, the differences. Interfaces cannot contain ordinary instance methods or instance variables, but they can now contain default methods, which are a special kind of instance method. Interfaces cannot contain constructors. Recall that abstract classes can contain constructors, but they can only be called by the constructors of subclasses. We conclude our discussion on interfaces by discussing 2 predefined Java interfaces that are frequently implemented. They are comparable and clonable. Implementing the clonable interface provides the ability to make deep copies. Clonable is a special kind of interface called a marker interface. If we were to look at the definition of clonable, we would see that it is an empty interface. Nonetheless, by implementing this interface, the expectation is that we will provide a method named clone that calls the clone method in object. Implementing the comparable interface enables deep comparisons to be performed. That includes not just comparisons for equality, as with the equals method, but in effect the equivalent of all 6 comparisons that the relational operators would provide. Beginning with Java 5, that included the syntax of generics, it became a generic interface. For backward compatibility, it can still be used as an ordinary interface, which is how we will use it because we have not yet discussed the syntax of generics. Implementing comparable requires defining a compare_to method, which compares 2 objects and returns a negative value if the first is smaller, a 0 if they are equal, and a positive value if the first is larger. Let's consider an example that illustrates implementing these interfaces. Notice that the comparable length class implements the predefined interfaces clonable and comparable. First, let's look at the clone method that should be present whenever we implement clonable. Every clone method looks exactly like this one. It makes a call to the clone method in object and returns what it returns. Next, let's scroll down so we can look at the compare_to method. Notice that the type of the parameter must be object. That means inside the method it must be downcast to become a comparable length object so that it can be invoked on the 2inches method. The 2inches method is invoked on both objects and their difference is returned, which is how a compare_to method is customarily written. By subtracting the 2 values, a negative, 0, or positive value is returned in the fashion that we have previously explained. Now let's examine the deep lengths class that contains a main method to enable us to test the comparable length class. It instantiates two comparable length objects. It then calls compare_to compare those two lengths. It then clones the first length and then performs both a shallow and deep comparison of the original object and its clone. As we have often suggested, this is a program that you should use to test your understanding. Try to predict the output of this program before we run it. Okay, so we've run it. We see that the compare_to method returns a -6, indicating that the first length, which is 1 foot, is smaller than the second, which is 1.5 feet. The shallow comparison with equal returns false because they are different objects. But the deep comparison returns true because they are clones.